Welcome to Practical AI, everybody. My name's Jeff. I'm with Peter Lynn. Peter, a couple weeks ago, we were talking about Stability AI and their troubles. Their CEO stepped down and they don't have a lot of money anymore, burning money too fast. And we kind of hinted at the fact that at some point we were going to discuss who's going to win in the end. If we had to predict who's ultimately going to make it to the top at the end of this sort of AI race and this sort of battle of empires, if you will. What's your guess?
My guess is I don't know, but if I had to pick one, I would probably pick either Apple or Google, mainly because they have the hardware and the software.
Okay, so explain the hardware and the software components and why that's important relative to the awesome model right now that OpenAI is, kind of built out and other people are chasing.
Right. Well, so OpenAI has their awesome model, but it has to run on expensive cloud hardware. And as people have noticed, the responsiveness of ChatGPT kind of ebbs and flows depending on how many people are using it. Some days it's fast, and other days you can just watch it like slowly type out a sentence, and you're like, why is it so slow?
So it's using other
Right.
people's hardware essentially in processing power, and a lot of people slam that thing and it just slows down.
Yep. Well, and not only that is sometimes it crashes and then, like it just is really slow. So, and that's just a problem of as you scale up language models, you need more and more more GPUs. And it's not like you just add more GPU and it just magically works better. Like there's a whole bunch of complex software stuff happening between when you punch in like what is the best place to learn how to cook. That gets sent to the cloud, and then there's some process that schedules it, finds a right server that's free, sends that to that server. The server does this thing, it sends stuff back. And so this is complex coordination of like users versus hardware. And sometimes if some servers crash, well, then there's less resources. And so then you have to wait longer.
Okay, so back to Google and Apple. What puts them in the catbird seat for this problem and solving it?
Well, Google has their own processor called TPU, Tensor Processing Unit, and it's built for doing training and for inference runtime. Apple has their own cloud for training, but they have the neural processor on all their Macs, all the iPhones, all the A1, M1 processors have this unit built in. It's been in there for over a decade.
Okay, so you and I at one point were talking a little bit about the importance of having a processor that's capable of doing neural networks, processing neural networks. What's physically happening there? What did they do? What did Apple do at one point 10 years ago with their chips that made this possible?
Well, they recognize that photography, so from my biased perspective, I don't know if this is true or not, photography was getting more advanced and more complicated, right? Like you could take pictures at night in low light. Well, the way that it does it is it takes multiple photos and it uses machine learning models to figure out like, oh, okay, it's kind of dark. Let's boost the contrast. Let's boost all these different things. And so it would take, instead of one picture, it would take like 12 or 10 or any number that I think it needs to take. It would process it and then give you a photo that looks like it's shot in a well-lit room. So they saw that. They're like, okay, to do this, we need a dedicated subprocessor called the neural processor to do this so fast and have it not chew up your battery. Because you could do it on CPU, but it was slow, right? Like, so if you took a picture, it would take it 10 or 20 times or 100 times longer to do this process. If you were on the GPU, it was fast, but it hurt your battery because GPU kind of chews through battery power very quickly. So like, okay, obviously that's not a good thing. So they thought, okay, let's build a special chip, put it in there called the neural processor that does this very fast. And so they did that.
Okay, so typically when we talk about processing, we talk about CPUs, which are in most PCs. We talk about GPUs, which is what NVIDIA's built an empire on. And what you're saying is that they did something different, not uncommon, but they took their model essentially and burned it directly into a chip or the up. Explain that a little bit.
So they looked at what models do at runtime, and they made a general purpose unit made especially to run models.
Okay, okay. And so Apple did that for photography, but it's more general than that. It can do a
Yeah.
lot of stuff, right?
Yep. It can do it for text to speech. It can do it for voice recognition, photography. It can do it for face recognition. So it's kind of like if you were to take a GPU, strip it down to the bare minimum, so they can run these models very quick. That's what it is.
Okay. All right. So they they got out ahead of this, and what's the biggest advantage of having your um like specific processing specific chip, model processing specific chip in all the external places, as opposed to processing the way OpenAI does it in some cloud somewhere?
But mainly, so the Apple sells it as a privacy thing, right? Because a lot of people back then were like, "Oh, I don't want to send my data up to Google for them to process on the cloud and send it back." And so their pitch was, "Hey, this is for privacy," but really it was to save on power. If it's running on your MacBook or your iPad or your iPhone, Apple's not spending money on electricity and cooling. Like you and I are paying for the battery power, and so it's much cheaper, right? Whereas Google runs on the cloud, and sure, they have a lot of hardware. They have racks and racks and data centers of TPUs, but that's expensive and it's hard to set up. And if they want to expand their TPU footprint, well, they got to look at do I have space in my data center? Well, if I don't, I got to build a new one. I got to go to TSMC and get the chips made. I got to have some other company build the cards and put it all together, and then I got to assemble it. And I need a whole team of engineers to build these TPU pods, and then go to the data center and set it up. So it doesn't happen overnight. Obviously, it takes months to do this stuff. Whereas if it's running on a phone or a MacBook, it's just on the device.
Okay, and there's trade-offs there. Obviously, you can't run massive
Yep.
models that are, monoliths on your iPhone, obviously, yet, or at least, that particular solution. What's Google done? Something similar?
Yeah. So Apple was the first to put in neural processors, and then eventually Qualcomm and Samsung both started adding neural processors to their offerings, right? So eventually they caught up and said, okay, yeah, we also need neural processors because we want to do these cool photography things or voice recognition or Google Assistant. And we don't want to have to send up the cloud because, well, it could be slow. If you're like out somewhere and you've got poor cell service, sending the voice up to the cloud to process and then send it back to your phone, like that's just kind of slow.
Okay, so and if I know you hate doing this, but if you had to pick one between Google and Apple, not that there's going to be just one someday, but if there were to be just one, who would you bet your money on?
I would say that in the long run, it's probably going to be Apple because Apple's really good at doing both hardware and software together. Whereas right now, Google is really good at hardware for themselves. But hardware for themselves is different than hardware for consumers.
Interesting. Well, and Apple has always had a war chest of money. They've got I mean, at least they're kind of known for their innovation. I wouldn't say that Google's not, doesn't have their own innovation,
Well, and
but
they're moving very fast. I mean, when the M1 first came out, that was back in 2020. And already this year, they're saying they're going to release the fourth version. So they've had basically a new version every year, which is unheard of. If you compare Intel from 2000 to 2020, Like it's usually like every other year you got like a major improvement. So it's what Intel calls tick-tock, where a tick is a major improvement. I mean, a talk is a major improvement, tick is a minor improvement. So they would be like, here's a new version of the process of the CPU. The next year they have like it's a little bit faster, maybe a little more memory, but it's basically still the same. And then the next year be a significant improvement that was anywhere from 5 to 20% improvement, right? Except for the last 8 years, they've been stuck. So they haven't really had much improvement because they had issues.
All right, so write it down, everybody. Peter Lynn says bet on Apple.
Well, no one
I'm
knows.
kidding. I'm kidding. Peter, this is a fun discussion, though. This is kind of thinking a little bit into the future, but also it helps us understand a little bit like what goes on underneath the covers here. And Apple kind of crowdsourcing their processing is really an interesting model going into the future, especially if we move away from monoliths and get into a little bit more distributed
Yeah, yep.
processing.
Yeah, and actually Meta just released Llama 3 this week, which their 70 billion version model is actually comparable now to a GPT 3.5
Oh, wow.
or 8. So already we're seeing this trend of like, yeah, smaller models are getting really powerful. And it's gonna get to the point where, like I'm gonna guess that by next summer, there's gonna be a smaller version that's not 70, maybe like a 40 or 50 billion per annum model. That if you quantize it down to 4 bits, that'll probably run fine on a mobile device.
Wow. Well, keep an eye on Mistral, right? With
Yeah.
an Apple device. That's could be the future. All right, Peter, this is great. Thanks for the discussion. Like, subscribe, ask questions. We'll try to answer them, and we'll see you next time with more good discussions. Take care, everybody.